In this video, we are going to solve exercise 1.4 question number 3. The question is, the following real numbers have decimal expansions as given below. Decimal expansions are already given to us. In each case, we have to decide whether they are rational or not. If they are rational and of the form P by Q, we have to tell what can we say about the prime factors of Q. So understand the question carefully. We have already been given decimal expansion. We have to first of all figure out whether the decimal expansion are rational or not. If they are rational, definitely they can be written in the form of P by Q. Then we have to say that what will be the prime factors of Q, which means what will be the prime factorization of the denominator. Okay. Now, here, this is the first subpart of question number 3. 43.123456789. We can see that it is terminating, right? It is ending after a certain point of time. So we will write down it is, this decimal expansion is terminating decimal expansion. So, whenever we have a terminating decimal expansion, what kind of number it is? It is a rational number. And all the rational numbers we know, they can be written of the form P by Q. Now, over here, the prime factors of Q is of the form, definitely in the prime factorization, we will have only 2 and 5 as its prime factors. So, they will be of the form 2 raised to n into 5 raised to m, where the exponents of 2 and 5, which are n and m, they are whole numbers. So first of all, just check whether the decimal expansion is ending after some point or not. If it is ending, definitely it is a terminating decimal expansion. And if it is terminating decimal expansion, it is going to be rational number, which can be written in the form of P by Q. So the prime factorization of Q will include 2 and 5 only as its prime factors. So it will be of the form 2 raised to n into 5 raised to m, where n and m are whole numbers. Now this is the second subpart of question number 3. Clearly we can say that looking at this decimal expansion 0.120, 1200, 12000, 120, 4 times 0 we have, right? And after that we have 3 dots over here, which means it will not end, keep on going on and on. So therefore we can say that it is non-terminating. Definitely this decimal expansion is non-terminating, as well as there are no set of numbers which are repeating, right? So we don't have any pattern over here. We cannot see any numbers which are repeating after decimal expansion. So that's why it is non-terminating, non-repeating decimal expansion. So if it is non-terminating, non-repeating decimal expansion, so it is an irrational number. If it is an irrational number, we cannot write it down in the form of P by Q, and that's why we don't need to worry about what will be the prime factors of the denominator Q. Okay, so it is ending at this point of time only. So what we need to check over here, whether in the decimal expansion, is it terminating after a certain point of time or not? If it is ending, then we will call it as terminating decimal expansion. If it is not ending, we have to check whether is there any pattern which keeps on repeating or not. In this case, we got that there is no pattern which is repeating, right? We don't have certain digits which keeps on repeating over here. So therefore, we will say that it is non-terminating, non-repeating decimal expansion, and hence all the non-terminating, non-repeating decimal expansions are irrational numbers. So there's no point of expressing it in the form of P by Q, and we don't need to worry about what will be in the prime factors of Q. Now this is the third subpart of question number 3. 43.12345678 Now observe here carefully. We have a bar over here. Above 1, 2, 3, 4, 5, 6, 7, 8, 9, we have a bar over here. What does that mean? It means that this decimal expansion is written in this way. 43.123456789. Again you will have this pattern 1, 2, 3, 4, 5, 6, 7, 8, 9. Again you will have this pattern 1, 2, 3, 4, 5, 6, 7, 8, 9, and it keeps on repeating. It will not end. Okay, it will not end. So clearly what can we see in this decimal expansion? It is non-terminating because it is not ending at a certain point of time. It is non-terminating and repeating decimal expansion. Because 1, 2, 3, 4, 5, 6, 7, 8, 9, this pattern is something which keeps on repeating again and again. That's why we have a bar over here, right? So it is non-terminating, repeating decimal expansion. And all the decimal expansions which are non-terminating, repeating decimal expansion, they are actually rational numbers. So we can say, since it is non-terminating, repeating decimal expansion, so it is a rational number which can be expressed. We know that rational numbers can be expressed in the form of P upon Q. Now, what about the prime factorization of Q? So, over here, Q is actually not of the form 2 raised to n into 5 raised to n. Definitely, in the denominator of this rational number, you will have any other prime factor also apart from 2 and 5. So we can say that the prime factorization of Q is not of the form 2 raised to n into 5 raised to m, and hence where n and m are whole numbers, so we concluded that from all these three subparts, if it is a terminating decimal expansion, it is a rational number. If it is non-terminating repeating decimal expansion, in that case also it is a rational number. Now, what about the prime factors of Q? So, if it is a terminating decimal expansion, the prime factorization of Q will be of the form 2 raised to n into 5 raised to m, which indicates that the denominator we only have prime factors as 2 and 5, not any other number, right? But whenever it is a non-terminating repeating decimal expansion, again it is a rational number which can be expressed in the form of P by Q. But this time, the denominator will have any other prime factors also in the prime factorization apart from 2 and 5. So the prime factorization of Q in this case will not be of the form 2 raised to n into 5 raised to m, and hence we can say it is a non-terminating repeating decimal expansion.